Welcome you in this video. The topic is serial communication using Arduino IDE. So the types of data transmission. The first type is serial transmission and the second type is parallel transmission. In the serial transmission, one bit is transferred at a time. Like you can see, the data is transmitted serially, so one bit will be transmitted at a time. So to transmit a complete word, suppose it is a 8-bit or 1 byte character, so it will transmit bit by bit. So this is called serial transmission. In parallel transmission, there are 8 such lines. So 8 bit of data will be transferred at a time. So very simple. The serial transmission, which is transmitted serially one by one, and the parallelly. In parallel transmission, the data will be transferred parallelly. So 8 bit of data will transfer at a time. So again, more detail. You see the difference. The serial transmission having the speed is very slow, and the parallel transmission it is fast. The cost is cheap, and in parallel it is expensive. Transmission bit, single bit will be transmitted at a time. In serial, in parallel 8 bit will be transmitted, because there will be one line in serial and 8 lines in parallel transmission. Usually serial transmission is preferred in long distances, and parallel transmission for short distances. For example, the printer is for serial data transmission with printer connection, and the modem what we use for internet connection to our laptop or the modem, so that will be parallel transmission. So this is the difference between serial and parallel transmission. Okay, now we'll focus on serial transmission. In a serial communication, the transmission is like this format. There is a protocol is given, like the start bit, the data bits, the stop bit. There is a baud rate. So what are these? Let's see. Whenever the data transmitted serially, so this uh, protocol has to follow. Start bit, it is always low, so whenever the start bit becomes low, so it will allow to transmit data. The data bits from 0 to 8, if it is a 1 character, so 8 bit will be there. So for example, 8 bit data you considered. Then there will be a parity bit, it can be odd or even. So it basically indicates the last character or last bit, so that it will show if it is a odd numbers or even numbers, so it will show there. Then stop bit, so it is always high, and the idle bit, so there will be no transfer between the lines. So this is how the data will be transmitted serially. So these are the bits which are available: start bit, stop bit, and the data bit, which are important thing. And what is this baud rate? Baud rate is simply the bits transfer per second. This is called BPS, bits per second. So in 1 second there will be a 9600 bits will be transmitted, and when we want to calculate time, so it will be 1 by 9600 seconds. So that will be the time to transfer that particular bit. So this is serial communication protocol. So here the explain again: start bit, which is a transition bit from 1 to 0 to transmit the data. Then data bits, which is sender and receiver have to agree on the number of bits which are transmitted, can be low or high, any of this. And the stop bit, which is set as 1 and indicate the end of the word. Now types of serial communication system. So there are basically 3 types. So one is a simplex type of serial communication system. So in that system there is a transmitter and the receiver, and the data will be transmitted only from one way, so that is from this transmitter to the receiver. So this is simplex form of serial communication system. Now the second is the half duplex form. So what happens, there are two lines, one is from this transmitter to receiver, the second is from this transmitter to receiver. That means suppose this point is A and this point is B, there will be a two-way communication. So we can send data from A to B and we can send again data from B to A, but there is a only one-way communication at a time, right? So data will be transmitted from this transmitter to receiver at a time, and then another time it will be transmitted from this transmitter to receiver, but not both time, both transmission at a single time. So it will transmit at a time. In third case, full duplex. Now there will be a transmitter and receiver, so it will transmit data in both way. That means it can transmit, suppose this point is A, this point is B, so and we have dual transmission, so it will transmit A to B and B will transmit B to A at the same time. So this is what the difference. In simplex there is only one way transmission, in half duplex there will be two-way transmission but one transmission at a time, and in full duplex there will be both way transmission at the same time. So this is what the difference. Again we'll see there will be a serial data transmission format. So one is this asynchronous data format and the second one is the synchronous data format. So we can see that. So what happens in this case, the data will be transmitted from this transmitter to receiver here also in two ways. One is asynchronous type and second is a synchronous type. Okay, so what is the difference basically? So this is the same as this is a serial transmission. So there will be a start bit, there will be a data bit, there will be a stop bit. So start bit always low to start the transmission, and the uh, last bit will be stop bit will be 1, and in between that there is a data transmission. So basically asynchronous data transmission format is based on character transmission. So it will transmit data at a time, only single character it can transmit. So this single character will consist of the data bit from D0 to D0. So that means 8 bit of data it will transmit at a time. So every time there will be a start bit, then the character will be there, there will be a stop bit, so it will transmit. So this is what the basic difference. So asynchronous data format will transmit a character at a time or 1 byte of data at a time. So this is called frame. And what happens in synchronous data format? It will transfer data, it will transfer packet of data. So we can see here data 1, data 2 up to data n. So it will transmit packet of data. So basically it sent the synchronizing character from this transmitter to receiver. So whenever there will be a this character transferred, after that this character transfer, so it will send the packets of data from this transmitter to the receiver. And another difference we can see, there will be a different clock pulse given to this transmitter and receiver in asynchronous, and the same clock pulse will be given to synchronous data format. So again we can see here the difference I have added here. So asynchronous data, it is used to transfer one character at a time, and it is used to transfer a block of character at a time. So this will transfer one character at a time, and it will be transfer packet of or block of data. Used for a data transfer rate below 20 kbps. So this asynchronous having the data rate transfer is low because every time it uses start bit, stop bit for each character, and that's why here the rate is low. And in synchronous type of data transfer, it is used for high data transfer rates which is above 20 kbps because there is no start bit and stop bit. In fourth point, two separate clock inputs are available or are used for transmitter and receiver. There is in synchronous, one clock is used for both the transmitter and receiver. You can see here these separate clock pulses, and there will be only one clock pulse. Synchronizing character are not transmitted along with the character, right? But there is a synchronizing character transmitted along with the group of character. In last point, the speed is less because overhead are more per bytes. Start bit, stop bit, these are required for the byte. So the speed is low in asynchronous, and the speed is high because of overheads are spread over a frame or packet of data. So this is the difference between asynchronous and synchronous type of data formats. Now in Arduino, what happens? There is a serial communication. So data will be transferred serially. Like we know, we connect USB with the help of mouse. We connect, then we connect keypads, printers. All these are having serial communication. So there is a transmission line TX and receiving line RX. So these two lines, TX used to transfer data and RX used to receive data. So every USB cable, it is having two lines and two lines for supply voltage. So this Arduino board, Arduino Uno board is having the mini USB port, and the cable is having mini USB to USB. So we can connect that Arduino board to the computer or our laptop. So it connects four lines from this USB to mini USB. So one is a positive voltage, one is a negative voltage, one is transmitting line, and one is receiving line. So the data will be transmitted serially in case of this Arduino. So digitally that data will be transmitted as we upload a program from this computer to Arduino board, or we can see some type of data or the measurement on the serial monitor. So at that time data will be transferred from this Arduino to the laptop or computer. So this type of digital format will be transmitted. Information passes between the computer and Arduino through the USB cable, and information is transmitted at 0 and 1s, also known as bits. So this type of communication, serial communication, will be done in the Arduino. Okay, so thank you for watching this video.